I'm going to talk about generators, which I don't know if people would consider that to be a beginner topic or not, but I don't care. It's something I wish I knew when I first started out, because I would have done a lot of things differently over the years. So I'm going to go ahead and talk about it. But first, before I talk about generators, I'll just go over what a function is really quick. For those that don't know. So a function is just a way to take something you're doing repetitively and just put it in one place and call that place over and over again. So the way you do that in Python is with the def keyword. We'll just make something dumb that takes a number and doubles it. Or actually, for this to work, it's going to take a list of numbers and then send back a list of all those numbers doubled. So what this does is it assumes you're going to give it a list called nums, makes a new empty list, goes through the numbers you passed in, and doubles each one and adds it to this other list, and then sends that back. So if we start out with like 1, 2, 3, 4, 5, and then so what we get back is 2, 4, 6, 8, 10. So what's different about a generator, or I guess the drawbacks to doing something like this is, number one, let me do it a little different way here. Let's say I run this function and then store the result in a different variable called bar. So when I do something like that, I run this function and assign the result to a variable. Number one, all of that processing has to be done right up front. And two, however much memory it takes to store that result is going to be taken up all the time, whether I'm using all of that or not. So, I mean, in this case, it doesn't matter. I mean, it's not an expensive operation. It's not taking up a lot of memory, but you are going to end up doing things that are both either time-consuming to run, or really large objects, or it might be small objects that you just have millions of. And you don't want to keep them all in memory at the same time. So that's where generators come in. A generator is a lot like a function, but we're going to do, actually I'm going to open a new file. So what will be different is a generator will just process these things one at a time. So I don't need a new list to store the answer in. And I don't need to return that list. What I'm going to do instead is instead of return, you use yield, which I never spell correctly. Yeah, like I said. So now, let's see. So now if I try to print it, it just tells me that it's a generator object. It doesn't actually dump out the entire list. If I wanted to see what it is, I can do something like this. So now it just prints the result out one at a time. So it doesn't look that different on the surface, but one good way to demonstrate what I'm talking about is make this take a long time artificially. So it's going to take 2 seconds every time it doubles a number now. Let me go ahead and do that in the other one as well for comparison purposes. Yes. Oh, well, yes, I do want to do that. Mm-hmm. So if I run now, the original one, it'll take about 10 seconds probably before it spits out a result, because it's going through that entire list and doing whatever my fake expensive thing is before it can even return the results back. Maybe to make it even more obvious, I'll do this. What did I do there? Oh, wrong one. All right, so the original one, you can see here, this is where it started and where I tried to assign that result. And then after 10 seconds, I'll get my answer. If I run the other one here, you'll see that I get the results one at a time. It's 2 seconds in between each one. And the other good thing here is that it's not storing all 5 of these numbers in memory. It's just the one it got, and then that gets thrown away and it moves on to the next one, unless you store it somewhere. So I guess the moral of the story is you'll find yourself doing stuff like this a lot. I've written a lot of functions in my life where I start out creating an empty list at the top and then putting things in the list and returning that. If you find yourself doing that, most of the time you don't need to. There are exceptions, but stop and think and see if you could use a generator instead with the yield statement. So, any questions on that? Mm-hmm. So, yeah, while it's running, it sort of keeps track of the state of the generator in memory. So we'll just do one here. No. I mean, I don't know. I mean, an iterator, I guess, I could be wrong here. Someone correct me. But that would be something that iterates over an iterable. A generator is iterable, like a list or a tuple or a dictionary. But it's not these same things an iterator, no. Yes, that is a true statement. Also, in Python 3, you'll find they've internally replaced a lot of things that used to just return lists with generators. So you'll run into generators that you didn't create a lot more frequently in Python 3. Let me see if this works. No, it's got to run the whole thing, but then I'll be able to use it. Okay. Do I have my list too? No. Okay. So I'll assign this to a variable. I'll just call it x. So you see that came back instantly. Let me do that again. Up here where you can see it better. So it did that immediately, even though it should take 10 seconds to actually do the work. It doesn't do the work until you actually call it. So if I look at X, you'll see that's just the generator like we saw before. If I want to start using it and going through things, I can just call next on it. I mean, you won't do this very often, but this is what happens. Like when you're in a for loop, this is what Python is doing, is it's just kind of calling next on the generator until it runs out of results. So you see that one. And so it kind of knows where it is in the sequence. And then after this one, I should get a stop iteration exception, and that's how you know that you're at the end. So if you were, iterating over this by hand for whatever reason, you could just call next and, like do a try. Well, this is beginner. I don't know how much you know about try except blocks, but you just look for that stop iteration exception, and when you see that, you just bail out and know that you're done. I believe that works. I know that works in a lot of the Python 3 stuff, but I don't know if they've done anything special. We can find out. I mean, I have to reset this. So we would say 8 in X. Now it may have to go actually run everything. Yeah. So you can do that, but it has to, I don't know if it goes until it finds it and then stops, or if it has to go through the whole thing, but. Oh, see if it ends quicker, yeah. Let's start it over. Yeah, so that only took 2 seconds, so it just stops when it finds it. Any other questions? All right, well, that's all I had.